sure you write down every piece of note on these bar graphs. We need this, as our common assessment will be coming soon. Stop looking at these bushy eyebrows and just write your notes. Alrighty, our next topic here is interpreting bar graphs. So, make sure that you copy every part of these notes as you're going to need it. It says a bar graph is a great way to compare categorical data. It can be represented both vertically or horizontally. Remember that vertically means up and down. Horizontally is side, left to right. The longer the bar, the greater the value, and the sum of all the bars represent the total pieces. So when we look at the bars, we need to find out what the total parts complete is. So at some point, we're going to have to add everything. So it says a brown paper sack is filled with colored tiles for a science experiment. How many tiles are in the brown paper sack? One thing I like to do is to kind of put my numbers right immediately here. So I know that this one is 20. This one is 8. This one is 12. And this one here is 10. So what happens is when I add all these up, I end up with 50 tiles. Okay, there were 20 red, 8 blue, 12 green, and 10 yellow. Let me make sure I check myself. Yep. Alright, so now I know the total and I know how much of each. It says what percent of tiles are blue. So there were 8 out of the 50. And if we're trying to find percent, remember that means over 100. And we can see that this changes times 2. So it's going to be 16%. Okay, if you don't remember that, then you can cross multiply and divide and get that answer. Number 2, what percent of the tiles are green? Well, green was 12. So 12 out of the 50 were green. And remember that percent means out of 100. So the same thing, we're going to multiply by 2. So that means that it's 24%. Number 3. What colored tiles make up more than 60% of the sample? Well, more than 60% of the sample. So if I take 50 times 0.60, because that's 60%, that's 0, 0, 0, 30. So we're looking for more than 30. Which one is more than 30? So red and yellow, red and green would give us more than 30. So red plus green. Okay. Number 4. How does the number of blue and green colored tiles compare to the number of red tiles? Well, when I look at this, blue plus green, because it says to compare them together, that's 8 plus 12. That equals 20. That is equal to red. Okay, that's the answer there. Now remember that this is a video, so you could pause it and make sure you go back and get what you need. Number 5 says, write 3 statements about the graph below, 2 that are true and 1 that is false. So one thing that I could write that's true about the graphs is there are half as many yellow as red. Another true statement is that green tiles, so green, account for more than 1/5 of the tiles. And once that is false, red plus yellow combined account for 30% of the tiles. Now really, for that false one, you can almost make up anything. You just gotta make sure that it's relevant to the information given. So that's page 1 of the notes. Again, make sure that you're getting this information because you're gonna need it to complete the worksheet. More importantly, you're gonna need it as we move forward. I hope to be back tomorrow, but we'll see. So then in the second page, we have Mr. Reynolds creates a graph of the numbers of students who have birthdays in the first half of the year. Use the graph below to answer the questions. And this graph is going to pertain to questions 6 through 9. So everything on the left side. So again, one of the things that I like to do is to number these already so I don't have to keep looking. So that's 16, that's 10, that's 18, that's 15, that's 5 and 11. And then once I do that, if I add them up, I will already have my total. But the first question is asking me to do that. It says determine the total number. So that's 16 plus 10 plus 18 plus 15 plus 5 plus 11. They're not always going to ask you to do that in the first question, but in this one, they do. When we add all those, we get 75 students. Okay. Number 7. If this is a representative sample of the entire 450 students in the 7th grade, then how many students will have birthdays in February? So this is just a sample, and in the sample, 10 out of the 75 have birthdays in February. But there's really 450 students total. So we want to find out if 10 have it in 75, then how many would have it for 450? Well, I can reduce this fraction first. That becomes 2. I mean, not 2. 2. We divide by 5. That's 2 out of 15. And we still have x over 450. And now we can cross multiply. And 450 times 2 is 900. And we're going to divide that by 15, which gives us 6. So it's 60. 60 students will have birthdays in February. So remember, notice that I reduced the fraction first. Number 8. Based on the information in the graph, which 2 months are responsible for a combined 20% of the birthdays? So this is based on the information on the graph. So that's 75 times 0.20. 0, 0, 10, 14, 15. So we're looking for 15 people. When I go back to the graph, that's what, 2 months. So April's 1 month, but 2 months to give me 15. That's February and May. February and May. Okay, I understand that April had 15, but it says which 2 months? February and May. Then it says, based on the information in the graph, in which month do 24% of the students have a birthday? So they only want 24%. So again, 75 times 0.24, 20, 28, 30. Move it over, 10, 14, 15. So we're looking for 18 people. Which month has 18? That's March. And that one is only 1 because it said which month, not which 2 months. So this is the left side of the worksheet. Now we're going to use the next graph, or the next bar graph, to do the right side of the worksheet. So it says a random sample of Washington, D.C. residents is conducted to see how residents commute to work. Use the graph to answer question 10 through 12. And again, we want to label these already because it'll help us in the long run. When I add those, I get 60 total. And I added them because the first question this time does not ask me to add them. It says, what percent of workers surveyed ride the metro to work? The metro. So that's 27 out of the 60. So 27 out of the 60. And it wants percent. So remember, that's out of 100. So we can reduce the fraction. And when we reduce this fraction by 3, we get 9 over 20. Now that helps us a lot because this changes times 5. So if I multiply 9 times 5, I get 45%. Again, remember that this is a video, so you can pause it and go back. If this is a representative sample of 500 residents, then about how many people can be expected to walk or bike? Remember that or means to add. So walk is 18 people. Bike is 11 people. So we're looking for 29. We're looking for, we know that 29 out of the 60 people originally walk or bike. And it says, about expected. So we know that we are then trying to find out how many out of 500. 29 over 60 does not reduce. Therefore, since it says about, I'm going to call this 30 for now. And here's what it does. It allows me to say half. So if half of the people, that's about 250. See? About. And I can answer that with an about. Okay? And the last one. Which of the following statements best represents the data above? So 35% of workers surveyed walk to work each morning. So walk to work was 18, so they're saying that's 35%. So let's take 60 times 0.35 and find out that's 18 people. That's 0, 30, move it over, 0, 18. Nope, that turns out to be 21 people, so that's not right. Part B, 1/4 of workers surveyed ride a bike or drive. Well, remember that or means that we're going to add. So bike is 11. Drive is 4. So we're looking for 15 people. 11, 4. We're looking for 15. Well, 1/4 of 60. That means that we're going to take 60 divided by 4. And that is 15 people. So the answer is B. And that's what the right side looks like. That's our notes for today. Again, make sure you write down your notes, turn them in, and make sure you do the worksheet. There's only 7 problems, and turn them in.